All right. So this kind of relates to the problem we just did. Okay. If I ask you to factor some long cubic polynomial, there's no greatest common factor. There's really not quite enough information for you to start factoring that. Okay? What if I was nice and decided to give you one of the factors, and then asked you to figure out the other ones? Would that possibly be helpful? If you're a little bit unsure, think of this. I need you guys to factor the number 1,296. I need you to go ahead and factor that one. Can you just rattle off all those factors? What are they?
I can't.
Okay. But could you make a factor tree?
Yeah.
Why? You know 2 goes into it, right? You know 2 goes into it, so therefore you know that this would be 2, and then how do you figure out that other number? You take this divided by 2. You know 2 is a factor, so if you take 1296 divided by 2, and that gives you 648, and then you can kind of keep going from there, right? Again, do you know all the factors of 648? No, but you know 2 is again a factor because it's an even number, so you could divide by 2 again and keep going until you get down to the stuff that you actually do know, right? Until you get down to small numbers that you can actually work with. So you can divide by 2 again, you get to 324.
Can't
you just do 648 divided by 8 minus 8?
Sure, you could try and find bigger numbers, couldn't you? Yeah, there's lots of different ways to do it. Here's the key thing that I'm getting to, though. In order to factor something like this, where you just can't automatically list all the factors, couldn't you divide this by something you know is a factor to help you figure out the other ones?
Yes.
Keep that thought in mind. If you're trying to factor some number, and you don't know all the factors, you could divide by something that you know is a factor to help you figure out the other ones. Okay? So now, going back to this. Let's say I want you to factor this. Let's say I tell you that x plus 2 is a factor. So let's say I tell you one of the factors. What do you think then you're going to have to do to figure out the other factors? I must not have made the connection. Let me go back here. Okay? 1296. Do you know all the factors? No. Do you know one of the factors?
Yes.
It's 2, right? If you know 2 is a factor of this, what did you do to figure out another factor? You divided it by 2, right? You took this and you divided it by the factor you knew, the 2, to get the other part of it, right? And then you did it again. And then you did it again, right? So what if you don't know all the factors of this, but I tell you one of the factors, what do you think you will have to do to figure out the other factors? Divide this by this, right? Does that make sense? Okay? If you don't know all the factors, but I'm nice and give you a hint that you have one of the factors, well then why don't you take this and divide it by the factor you know And that will help you figure out the other factors. Okay? So, we must divide 3x cubed minus 4x squared minus 28x minus 16 by x plus 2. Logically, does that make sense why we're going to do that? Because the goal is to factor that polynomial. Okay? Well, we don't know all the factors off the top of our head. Just like with the number 1,296. We didn't know all of those factors. Okay? But if we know one of them, we can use that one to help us figure out the other ones. By dividing. Okay? So now, how in the heck are we going to divide this by this? We've never divided polynomials before. That is a new thing that you will have to learn. Okay? I'm going to show you two methods. Alright? One of them is old school long division. Okay? 3x cubed. Help me out. 3x cubed.
Minus 4x squared minus 20x minus 16.
I'm going to divide that by x plus 2. Long division. Now we're recording this, so therefore you're probably going to have to come back to this video at some point, alright, to help you with this. Alright, I'm probably not going to teach it to you again, alright, you can just use the video again and again. Okay? Pretty self-explanatory, there's probably 100 videos, maybe some teachers do it better out there that you can watch too. So, here's how we do long division. First of all, let's bring you back. How would you do long division here?
4 goes into 39.
Can 4 go into 3? No. Can 4 go into 39?
Yeah.
Yes. How many times?
9 times.
9 times. And so you put that 9 right up here, right? Then what do you do with that 9? Times it by the 4 that's out front. 9 times 4 gives you 36. What do you do with that 36? Subtract it. And you get a 3, right? Then you drop the 2.
8.
And so on, right? This ringing a bell? Okay, I'm just refreshing your memory how to do long division. Here's how it works with polynomials. Okay? So, like here, when I said, okay, how many times does 4 go into 3 or 4 go into 39? Up here, you don't need to think how many times x plus 2 goes into this. You actually just need to think about the x. Okay? How many times does x go into 3x cubed? 3x squared. Because x times what would give you 3x cubed? 3x squared. So I can put my 3x squared right on top. Again, you think x times what gives me 3x cubed. Just like you thought 4 times what gets me as close as possible to 39. Okay? So far so good? After we came up with that 9 here, what did we do with the 9? We multiplied it by what was in front, right? So now I'm going to take this right here and multiply it by what's in front. Now I do need to multiply by all of that. So let's take 3x squared times all of this. What do you get?
3x cubed
3x cubed
plus 6x squared.
plus 6x squared. Seeing it? Then what do I need to do with that number? After I took 9 times 4, I got 36. What did I have to do with that 36? Subtract it. So I need to subtract this whole thing. Well, if I need to subtract a couple terms, I really just subtract both terms, right? So I'm going to subtract this and I'm going to subtract that. Because you're subtracting the whole thing. What happens here? cancels, that's good.
So just use
Negative 4x squared plus negative 6x squared would be negative 10x squared. So I got negative 10x squared, and then I drop down the rest, negative 28x minus 16. And now you repeat the process. How many times does x go into negative 10x squared?
Negative 10x.
Negative 10x. What are you going to do with the negative 10x? Multiply what's in front. So I get negative 10x squared minus 20x. What do I need to do with that? Subtract it. So when I'm subtracting this, I got to subtract all of it, right? Well, when I'm subtracting negatives, I actually end up doing what? Adding.
Those cancel.
Those cancel.
Goes with 8.
Negative 8x. X times what gives me negative 8x?
Negative 8.
Negative 8. Multiply by what's in front.
Oh.
Subtract it. There's your answer.
Are they all going to work out nice like that?
If I give you a factor, it absolutely has to work out. Because if I give you something that is a factor, that means it goes into it evenly. Like you knew 2 was going to be a factor of 1,296, right?
Yeah.
So it's definitely going to go into it evenly.
Yeah.
If I give you a factor, yes, absolutely, they'll all work out nice. Okay, how am I doing on time?
11 minutes.
Okay?
12
Trying-
actually.
Yeah, 12.
Okay? So, 3x squared minus 10x minus 8. What was my original again? 3x cubed.
Minus
Minus
4.
4x squared minus 20x minus 16.
Okay. Well, now, you told me that x plus 2 was a factor, right? When I divided this by x plus 2, what did I get?
3x squared minus 10x.
Minus 8?
Yeah.
So now I know that this times this
What's that?
would equal that, right?
Are you done?
Not quite, because I think I know how I can factor this now.
Yeah.
This is a quadratic. This is what we spent all chapter 4 factoring. Unfortunately, this one's going to take the special factoring trick. Okay. Okay. Real quick, special factoring trick. 3 times negative 8 is negative 24. What multiplies to 24 and adds to 10? Oh, it's going to be a negative 12 and a 2. I divide those by 3. I reduce. So 3x plus 2. 1x minus 4. Not quite sure, double check your work by foiling it back out. 3x squared minus 12x plus 2x gives me that, and then minus 8. Can I factor it any further? Nope, you're done. Now it's factored. Go ahead and stop it.